All right, we're back. So let's finish checking the conditions for the cat example. So we already discussed how we have a random sample of households for this because they just said that. So then we need to check approximately normal. Well, here's an issue. It doesn't say that it's approximately normal, and there's only 15 households. So the sample size is not bigger than or equal to 30. So when that's the case, you get the pleasure of creating a box plot. So this is the example that I'm going to review how to get a box plot. We did this 2 units ago or last unit, so you should know how to check with a box plot. Remember, I'm going to always look for that really quick sketch, and it has to be somewhat accurate. So I'm going to go to Stat Edit. I technically already have that data typed in because I'm recording these videos all on the same day as of right now. So to be nice to you guys, I'll go ahead and retype it in. So type in your data. Then to turn on your box plot, remember that's going to be second y equals. So second y equals, we're going to turn plot 1 on, and then you're going to change that to your modified box plot, the one with outliers. So we're going to hit enter on that. And then after that, you just hit zoom 9. So zoom 9. And I'm going to do a quick sketch of this box plot. When you do this quick sketch, you do not need to scale your axes or anything. We just need to see a quick sketch of it. So it looks something like this. And I would know whether or not you saw this box plot or not, because notice how the median's not graphed in the middle, okay? The median's either at Q1 or Q3. So you need to sketch what you actually see on your screen to get full credit for your sketch. So remember, with a box plot, you're looking to see if there's any apparent outliers, which there are not. So since there are no outliers, and the box plot is approximately symmetrical, never call a box plot approximately normal. That makes no sense. Okay, approximately normal is a curve. So the only thing you can look at a box plot and say is that it's approximately symmetrical. So since there are no outliers and the box plot is approximately symmetrical, then the distribution is approximately normal. So we only talk about a distribution being approximately normal, not a box plot, okay? So that will be worth points. So in this case, we have a random sample of households. We have an approximately normal distribution. So the conditions have been met. So the conditions, I'm just going to put this at the top because I kind of ran out of room. The conditions have been met. Okay. So that's the big point of today's lesson. But another thing we're going to do is talk about error. So yesterday, once again, just a flashback, we already did this hypothesis test. So we are trying to show that the town owns fewer than 2.1 cats on average, but we failed to reject HO, so we had insufficient evidence. So remember, when you have insufficient evidence, that means you made a type 2 error. Well, you didn't necessarily make it, but you could have potentially made a type 2 error. So this is a type 2 error. And all that means is that we have insufficient evidence that households in this town own fewer cats than the American average, but they really do. So they really do own fewer cats. Okay, so you had insufficient evidence to say that, but in reality, it really was true. You just for some reason didn't get enough evidence the first time around if you made this error. So consequence of this error, once again, it could be tons of different things. Your mind might think differently than mine. But what I thought of right away, okay, if they really do own fewer cats, but this town now thinks that they don't, they may have more pet stores or adoptions. So maybe people will be less likely to adopt because they think that 2.1 cats is enough. So I'll just put that, less likely to adopt a cat, something like that. So not like super detrimental, but you do need to realize that you just need to think of some sort of consequence that can happen based off that conclusion. So if they didn't think that they had fewer cats in the household average, but really they do, maybe there'll be more pet stores, like a local business might pop up, and then they'll go out of business because they really do own fewer cats. They don't need as much cat stuff. So yeah. Okay, so our last example today that we're going to check examples for, we are not going to talk about error only because we're not going to actually do the full hypothesis test for this one, is about soda. So cans of Dr. Pepper are supposed to contain 355 milliliters of soda. There is some variation in the filling process. The mean content of 6 randomly selected cans is 352.26 milliliters with a standard deviation of 2.113 milliliters. These data are approximately normally distributed, and they want to know, is there convincing evidence that the mean amount of soda is less than 355 milliliters? Well, today we're not going to find whether there's convincing evidence or not. Today, we're just going to check the conditions. So the first condition, is this random? They literally said this right here. So we have a random sample of cans. Once again, you always need to tell me what your sample is of. Make sure you include that. Then this one is the dream problem, right? You don't even have to check sample size. You don't have to check a box plot, none of that. They literally said the data is approximately normally distributed. So since the problem states the distribution is approximately normal, the condition is met. So they just told you, so you can assume that condition's met. So since we've met both conditions, the conditions have been met overall, which means if I did ask you to answer this question, is there convincing evidence that the mean amount of soda is less than 355 milliliters? You could, because now the conditions have been met. You can create a set of hypotheses, find your test statistic, your p-value, and make your conclusion. So today should have been a review lesson, if you ask me, only because we've checked these conditions before, not for these problems, but we did very, very similar work when we were checking conditions for our confidence intervals last unit when I was here. So let's see the homework for tonight. Go ahead and flip, okay. So the homework for tonight is going to be on page 11, 12, and 13. So page 11 through 13. It is going to be numbers 1 through 6. And this is going to be counted as 29 problems. Okay, the reason why it's going to be counted as 29 problems is because for 1, 2, and 3, you have to check the conditions. So you have to have 2 sentences for 1, 2, and 3. So 1 through 3, 2 sentences. Okay, because you're checking your condition. And if you have data, you do need to have your box plot, so that way you can show that you check that condition. Okay, now the only time that doesn't really change is, or does really change, is if it doesn't meet the first condition, you don't even have to check the second. Okay. Then numbers 4, 5, and 6, you're going through everything. So numbers 4 through 6, anytime they talk about conditions, you need 2 sentences. So conditions, and I'll zoom out because I know I'm not going off. Conditions equals 2 sentences. And you have to show box plot where you have data. So for example, on number 5, you better show a box plot. And then your calculations and hypotheses, your null hypothesis and your calculations, just null hypothesis, alternative, t-test statistic, p-value. Your conclusion should be 2 sentences.